Thank you, and hello everyone. My name is Mircea. I'm leading the machine learning operations engineering team at Raiffeisen Bank Romania, specifically in the AI and the agentic team. But fear not, this conversation will not be about AI or agents. I think we had enough of those already. Today, I want to present to you more of a case study of GitOps in the wild and how we run FluxCD at Raiffeisen Bank. So, my opinion, personally, is that setting up FluxCD takes about 10 minutes. You know, you do a Flux install via the CLI, you bootstrap it, or maybe you helm install the operator and then set up the Flux instance, you point it at a Git repo, and essentially, that's about it. At that point, Flux will manage your manifest via GitOps. This talk is about everything else that's required to make that work for you. And to give you an idea of the scale we're operating at, we have over 200 repositories at this point in Git that we are managing over 75 apps. I think we're close to 100 at this point. We have 5 Kubernetes clusters. 3 of them are in EKS, 2 of them are on-prem, and we're doing all of that with a 4-person team. So, what I have planned for today is to take you along with me on a small journey, going from an idea to production, and I want to show you what we automated and why. So we're going to start off with a use case being formulated by the business. So generally speaking, somebody from the business side will come to us with an application. They have something that they think they could be solved with AI or ML, but that doesn't necessarily matter. And we're going to start off, we don't even have a Git repository, so we need to somehow set that up. Then we're going to have to boilerplate some sort of project structure to get things going. Once we write the code, we're going to need some way to deploy it. And finally, once all of the application is built and deployed, we're going to get to the hard part, which is actually keeping it all up to date over time. So let's start off with the beginning. I got a use case from business, and I need to make an application for it. Cool. One of the first things that I need to do is to create a repository for that. But there are problems with making repositories manually. For every new repository that we create, we need to set up branches, branch protections, required status checks, team access, collaborators, permissions, action secrets, variables, runner group assignments, repo level settings, topics, and so on and so forth. And it's quite a bit. And you have to do that manually every single time across 200 repositories. And even that wouldn't necessarily be the end of the world. But let's say we need to change some repo level settings. Now somebody has to go manually through 200 repositories or even more to change those settings. And drift is bound to happen. So here's what we did. We have some OpenTofu and TerraGrant configuration. Quick show of hands, how many of you have used OpenTofu or Terraform by now? And how many of you have used TerraGrant before? Do you know what that is? Okay, so for those without raised hands, essentially speaking, TerraGrant is just an orchestrator of Terraform or OpenTofu projects. You can have smaller individual projects instead of a big monolithic one, and then TerraGrant will say, okay, this one goes first, you take the outputs from this, you apply that, then those two go in parallel after that one was done, something like that. So what we did to automate all of this GitHub infrastructure is that we set up reusable OpenTofu modules that are opinionated for what we have in our organization. And then we have modules for setting up repositories and teams within our GitHub instance. Then, whenever everyone needs to create a new repository, they basically have to set up this TerraGrant unit that calls that module. And the main advantage here is that in our case, every single repository and every single team is a dedicated unit, so it means that it has a dedicated state file. I could work on a PR to set up a new repository, somebody could work on another repository, everyone in this room could work on their own repository, and we wouldn't run into issues with state locking or anything like that, because every single repository has its own state file that doesn't lock with the others. So this means that work on PRs is non-blocking. When CI plans or posts the Terraform plan as a PR comment, it doesn't block anything else. Everything just happens in parallel. And the advantage here is that when we run PRs, as I said, the CI runs and then posts your plan output as a comment. When you merge it, it gets applied. And this would technically count as GitOps, I guess, because it's in Git and it manages your infrastructure state. But a big part of GitOps is actually the reconciliation loop. And the poor man's approach to that, I guess, is that we also have a GitHub Actions workflow that does the TerraGrant apply, but it runs on a cron schedule, so like every hour, even if somebody were to somehow get admin access and start changing repositories, on the next hour, everything would be set back to what we want to do. One of the main advantages here is that, again, if I need to change a repository level setting, I can just update the module, PR the change, I will get a comment to see how everything would be impacted, and when I merge it, all of the repositories are now suddenly up to date. So what does that look like for our developers? Like, what's the developer experience? Well, how many of you have heard of task file? Anyone here? Okay, Makefile maybe? Have you heard of Makefiles? Have you used them? Okay, essentially speaking, task file is like Makefile, but 2025. It's like a bit better, I would say, but maybe I'm biased. So essentially, as a developer, you just clone that GitHub infrastructure repository. You run a task repo create, which is the equivalent of like make repo create. And that will ask you some prompts, like what's the name of your repository, what team needs access to it, and so on and so forth. And using those answers, it will template out a new Terra Grant unit. We can push that to a new branch, PR it, then the PR will have a comment saying, okay, this new repository will be created, it will have some variables, it will have some teams with access to it, and then somebody from the ops team will review that PR and just merge it. And the reason that I used a different color for the fourth step is that that is the only step in which the ops team, so like the 4 people I mentioned earlier, need any interaction in the process. The first 3 steps are fully on the dev side. So, at this point, we create the repository, so that's cool. We have somewhere to put our code. But generally speaking, when you set up an application, we're mainly a Python shop, so we set like a Fast API or Django projects. You have some sort of boilerplate, at least in the terms of your usual CI, linting configuration, maybe some best practices for Docker files, so on and so forth. The problem with setting up that manually is that generally speaking, how it starts, I mean, let me know if it goes differently in your organization, but in my team, we had one project which was generally deemed in the team to be like probably the best one by far in terms of like the boilerplate around it. Somebody will copy it, gut it of everything, or almost everything that is not relevant to them, delete the part that don't apply, hope that CI will probably work and it didn't have anything specific to that application, but then each dev does it slightly differently. So you have drift from day one, bugs will most likely propagate silently because nobody will validate what they copied from another person. Improvements don't really scale because if I push an improvement down to one repository, maybe nobody will copy that one next time, maybe they will copy a different one. So there's no definition of good. We have no idea what a good boilerplate for our repository looks like. So, has anyone here heard of Copier, maybe, if you work in Python? Wow, a single hand, cool. You heard of Helm, probably. People here heard of Helm, right? Helm essentially is like a templating engine. You have your folder of Go templates and the values file, and when you run Helm template, it just templates that. It just so happens that we're generally using it for like Kubernetes manifests, but realistically speaking, it's just a Go template with a values file. You could use anything in there. Copier is mostly the same thing. It has a folder full of Jinja templates because it's in Python, and then it asks you some questions, which then maps to a values file, and then using the answers to those questions, it will render out the Jinja templates to a new folder. So what we did here is that we have a composable Copier template stack. We have our base template, which gives you all of the renovate, code QL, security scanning, task file automations, basically the stuff that is identical across all of the repositories, regardless if they are, I don't know, code repositories, infrastructure repositories, or whatever package that we might have. We have specific backend and frontend templates, which in our case maps to like Python services or JavaScript services, because we use Vue.js for frontends. And this will be brought on top of the base template, and it will give you like a folder for your microservice that has the specific, I don't know, what we deemed to be a best practice Docker file for Python, a best practice Docker file for a static JavaScript application, specific linting, specific tooling around that. It will basically give you all of the extra bits on top of the base template that are required for your specific microservice. And this way you can have like a monorepo with all of the microservices required for your app. And this way, all of the improvements are easily propagatable because we can release a new version of the template. There is now a clear definition of what good is. And let's say, secret weapon here, or the secret sauce, is that copier will also store what's called an answers file. And within that answers file, it will store the source path, which is the URL to the template repository that you used to copy. So you can run copier copy and then give it the URL to the Git repo, which holds the template. And it will hold that URL, the commit, which could be like the SHA or the Git tag you used to create the template, and then all of the answers to the questions that you provided. And the cool part here is that Renovate, if you've heard of it, it's like Dependabot. It's a tool that scans your project and pushes updates. Renovate can detect these answers files, and it has a built-in copier plugin. So what it will do, if I push a new update to a template, it will see that the new tag is no longer 2.5.1, it is 2.6.0. It will update that tag, it will run copier update, it will re-render all of the templates to be up to date, and it will PR it back to main. So it automates of our template updates. So what is the developer experience for that? We just created the repository. I talked a bunch about what copier is, but what do I, as a developer, have to do here? Well, I created the repository, as I said. I need to clone it locally. Then I need to copy the CI template. And after that, we have task file automation, so I can just do task copier, add backend. I will answer the questions like, what is the service name? What Python version do I use? Do I want it to be published as a Docker image, or do I publish it as a PyPy package? Same for a task copier, add frontend. What JavaScript version do I use? Do I want it to be published as an NPM package or as a Docker image? So on and so forth. And this will template out all of the folders and the required boilerplate for the microservices, except for all of the code, obviously. So you get your CI workflows that work from the day one, you get best practice Docker files that have been vetted by the ops team, you get all of your task file automation, so you don't necessarily need to remember what are all of the linting commands used across all repositories. Whatever Python package you are making, you can run task lint, and it will run whatever linting tools you need to validate that microservice. You get version pinning for Python versions and Node versions. Again, these can be updated by Renovate. And the cool part, again, is that it runs on automatic upgrades, because Renovate can detect all of this. So let's assume that I wrote the code. We unfortunately didn't get to the point of automating that. Cloud Code is working on it, but we're not there yet. So we assume that the development happened, and now we need to deploy the application. Cool. Well, before I show you how we're doing it, let me show you how it started so you can see how it's going. When I initially joined this team, it was only me, and I thought that I can just put everything into a single monorepo for deployment, right? That will probably scale. It will be good enough. Well, it turns out it didn't scale, and it wasn't good enough. We had the promotion coupling, because promoting an application A required a PR on the same repository as apps B, C, and D, and any CI failure would block everything. Ownership was also kind of impossible, because you can't give team A ownership of their own manifests without also giving them access to the manifests for team B, C, and D. And the blast radius was, essentially speaking, the entire platform, because a bad commit, let's say that I had a typo in a customization, well, then the Flux customization, which applies this repository, would stall for everything, and no other application could push the updates. And essentially what happens is that ops, or me at that time, became a bottleneck, because every new deployment, every new promotion, everything had to go through me. So what we did is that we moved from a monorepo to a fleet repository and then dedicated deployment repositories. You see here the before and the after structure, and what's the main takeaway is that before, in the folder for tenant A in our cluster, we had the namespace, obviously. We had the Helm release, OCI repositories, config maps, deployments, whatever. All of the manifests for the application were directly in the deployment repository. What we did after, when we migrated to the fleet repository, is that every single application, regardless of how complex it is or how many services it has, is only 4 manifests from the ops point of view. It has a namespace. Obviously, we have to create them for our tenants. You have a Git repository.yaml, which is a Flux manifest that points to the deployment repository of that tenant. An app, Fluxtomization, which points to the Kubernetes directory. We'll see that in a moment. And then a config Fluxtomization, which applies some Terraform code. Again, we will see that in a moment. So what does the deployment repository look like? Because I just referenced it. Well, this is based on another copier template, like I presented for the source code. We also have a copier template for the deployment repositories. And this, broadly speaking, gives you the following. It gives you a Kubernetes directory. which we as the ops team guarantee that in the Fleet repository, this will be what Flux runs a kubectl apply-k on it, essentially. So all of the plain Kubernetes manifests go in this directory. You're free to do more or less whatever you want within this directory. Then we have a config directory. Here, what we're doing is that we're using the Flux infrastructure as code controller for Terraform. So this essentially is just a single controller that controls a resource called Terraform. It links to a Git repository or an OCI repository or whatever source you may have from the source controller, and essentially it's a manifest for applying Terraform. You link it to the source, you give it a path, and it just runs Terraform apply within that path with some specified flags. In what folder it runs the apply? Well, in the Terraform folder that also comes from the template. This is where you put OpenTofu code for the applications that we run that are not Kubernetes native. Because at the platform layer, for example, we run Keycloak, we run Minio, we run LiteLLM, and while all of these are great applications, they are not Kubernetes native. I don't have a CRD to create a client or a Realm or whatever, a service account in Keycloak. So what we've done is that we have reusable OpenTofu modules for creating all of these resources and then exposing the secrets generated as Kubernetes secrets. So what you can do here is that you can reference the reusable modules we created for you to set up a Keycloak tenant, a Minio tenant. Maybe you want to configure a service account in LiteLLM to gain access to some large language models for your applications. Whatever you need from the platform that we have managed for the team, and it's not Kubernetes native, you can put here. And finally, of course, we also have some GitHub workflows, but the one that is, let's say, most important is the promotion workflow. This is a GitHub workflow that will promote your application from the pre-live environment to the production environment, and I'll show you in a moment exactly what that does. But before we do that, let's first get the application into pre-live, and then we'll get to see how we can get it in production. So, again, what's the developer experience here? What does a dev need to do in order to get their app on pre-live? Well, first, they need to create their deployment repository using TerraGrant if they haven't done that already. So we've seen that with the task repo create in the GitHub infrastructure repository. They need to scaffold their deployment repository with copier. So they copy the CI template, then they do a task add deploy. And this will render out all of the boilerplate with everything that's needed for them to start dropping in their manifests. They put in their Helm releases, OCI repositories, deployments, config maps, whatever. To help them out here, we also have quite a few Helm charts internally that are opinionated. If you need to deploy an MCP server, there's a chart for that. If you need the Django template, there's a chart for that. If you need a fast API server, there's a chart for that. So we try to template out everything as much as possible and have a level of abstraction that only exposes the important tunables, the ones that they care about, to the team. And finally, once you have your deployment repository set up and all of your manifests are, let's say, on the main branch, what you need to do now is you need to onboard it onto the Fleet repository. So somebody needs to clone down the Fleet repo and then add the namespace, the Git repository, and then the app and config customizations. And if this looks quite repetitive, well, that's because it is, and we also templated that. So you can just run the task copier add tenant, and it will ask you like the name of the tenant, the URL for the repository, and it will template out everything that you need. You can then PR that back to main, and somebody from the ops team will need to approve your PR, and then your changes or your application will make it to the pre-live environment. Okay. Let's say that you validated your application in pre-live and you need to get it to production. What do you do then? Well, as much as this might be a faux pas with the latest setup of Gitless GitOps, we're still using the branch promotion model for our deployment repositories, and so far it has worked quite well for us. What we're doing is the following. You can see here an example of a Git repository manifest for Flux. And what we're doing, you can see here we have a URL, which would point to the, of course, the deployment repository. So this will be the manifest in the Fleet infrastructure repo. And then you reference a branch. And here, we're using the Flux post-build variable substitution, which essentially will just replace that Git branch variable with the actual value we defined. And every cluster in our environment, be it production, pre-live, testing, has a specific variable for that Git branch that it syncs. For the pre-live environment, it's the main branch. So whenever you PR something to main and your PR gets merged, that change will make it within 1 minute in this example to the pre-live environment. The application will get deployed, you're free to test it, and if everything goes well, you can run the promotion pipeline, which will just rebase the production branch onto the main branch. So basically, it will get them both up to date. And the production branch is obviously heavily guarded. Nobody can push to it directly. What the promotion pipeline does is that it impersonates our service account, which is the only entity within Raiffeisen that is allowed to push to the production branch. And this way, we have a clear audit trail via the GitHub Actions history page to see who promoted what commit and when. And the production cluster has the variable set to production, so whenever you run this commit, once the PR is done, again, within 1 minute, your app should make it to the production environment. Cool, so the application is deployed, it's presumably right, nobody in the business complains, so that's it, the use case is done. Well, yes, but actually no, because there's still a big problem. In my opinion, this is where the hard part begins, because, coding, especially with all of the agents that are helping us now, it's not necessarily that hard or not necessarily the biggest bottleneck. The problem is that dependencies rot. Let's say that the upgrade from Python 3.10 to 3.12 happened quietly, and the Docker files didn't notice. Nobody updated them. You skipped maybe 3 major versions for a Helm chart, and now you need a new feature, but it's no longer an upgrade project, it's a migration project at this point. Maybe your GitHub Actions were still using a checkout v3, but somebody on the ops team upgraded the runners to the latest version, and now you no longer have the node version required in order to run that action. So all of your actions are now failing. Maybe we upgraded Keycloak, and the API is no longer compatible with the provider version that you are using. The problem is that, again, we have over 200 repositories with dozens of dependencies each. So it's simply thousands of updates per year. That's not manageable by such a small team. So we use Renovate, literally everywhere. These are some stats that I collected. I think this was for the month of May. We had 557 PRs opened solely by the service account. So this is only Renovate doing the work. This is besides the, let's say, human events. Out of those 557 PRs, 536 were automatically merged back to the main branch. So Renovate opened the PR, all of the CI ran, the linting, testing, validation, everything. And if everything passed, on the next run, Renovate will auto-merge that PR for you. You don't even have to touch everything. So if you do the math, that's a 96% merge rate. And mind you, I think that this number is quite low because not necessarily all of the CI finished running by the time I was making this statistic. So I think in actuality, it's closer to like 97, 98%. Okay, so what gets updated then? What are we updating with Renovate? Well, essentially, if it has a version tag, it's handled by Renovate. We're updating our container images, be them internal or maybe external from public registries. Helm chart versions, we use OCI almost exclusively, so OCI Helm repositories are updated by Renovate. Tofu and Terraform modules, we publish our internal modules as OCI artifacts in Artifactory, and then we reference those. We created a custom Renovate regex manager for that, so Renovate can pick them up as well. Python packages in your requirements.txt or pyproject.toml, Renovate handles that. GitHub Actions versions, Renovate handles that. Flux components, even the API versions in the manifests can and are updated by Renovate to match what your operator uses. Terraform providers, copier templates, literally everything that has a version attached to it goes to Renovate. And again, what I want to stress here as the most important part, because in my opinion, this is, let's say, the secret weapon for Renovate, because Dependabot, for example, can also update some of your dependencies. But Renovate has native support for copier to manage our templates. What this means is that, for example, if I push an update to the backend template and I make a security improvement to the Docker file, I can release the new version. Let's say that would be 2.6.0 instead of 2.5.1. On the next run, Renovate will detect the new tag. It will open a PR on all 200 repositories, and if everything goes, if everything passes in CI, it will also auto-merge that automatically. So I don't even have to bother. Nobody from the dev team needs to, bother with improvements from the ops side. Everything just goes automatically. So what is the developer experience for keeping everything updated? Well, as you've seen, like in this slide, 96% of the time is just this. This is what you have to do as a developer to make sure that everything is updated. Sure, you have to test your stuff on the pre-live environment because it goes straight to main, essentially. But yeah, other than that, if you validate everything, it should be just fine. And one important caveat here is that Renovate doesn't just auto-merge like absolutely everything. We use SemVer almost exclusively, at least for the packages that we publish as a service on the ops side. So if the update that Renovate detected is a minor or a patch, it just auto-merges that if CI passes. But if it's a major upgrade, so like from V2 to V3, it will hold the PR and hold it for manual review. But generally speaking, you don't push like breaking updates that often. So, wrapping it up, what's the TLDR here? Because I just talked a bunch, but what have I actually said? Well, in my opinion, GitOps isn't just a tool. I see a lot of conversations about GitOps, and it's mainly like, do you use Flux or do you use Argo? In my opinion, let's say the GitOps engine isn't necessarily like the big or the hard part, because fundamentally speaking, the actions that they're automating, they're not that complicated. If you think about it, Flux is just a bunch of controllers doing git clone or git pull for you, kubectl apply, and then helm install, or helm upgrade -- install. Fundamentally speaking, it's not necessarily the biggest problem. Again, like I said in the beginning, setting Flux up is like, 10 to 30 minutes. GitOps is the entire supply chain around that, in my opinion. And for us, that's OpenTofu and TerraGrant to manage all of our additional infrastructure that is not in Kubernetes, Copier templates so we can GitOpsify even our GitHub repositories contents, FluxCD, obviously for the Kubernetes side, and then Renovate to keep everything updated. And finally, I want to wrap it up with a few lessons learned. Yes, it's a lot of Git repositories, but it's GitOps at the end of the day, so that's kind of expected. And in my opinion, it is worth it. Like independent ownership and promotion, in my opinion, outweighs all of the management overhead. And to be fully honest, given that we have all of the templates and TerraGrant and Renovate in place, it's not even that much overhead for management. You set up a repository super easily, and then generally speaking, it's automatically up to date. You don't have to do that much. Branch promotion, while it works well for us, it does require discipline, and you need to have strong branch protections. You can't just have people willy-nilly push to production, obviously, or even to pre-live. Everything has to go through PRs, and in our case, the service account that we have in GitHub is the only entity within Raiffeisen that is allowed to push to our production branches. Nobody is allowed to push directly to production. And let's say, as 2 tips from me, as we've set this up, is that you need to invest in the developer experience early. Because however much automation you put in place, however many templates, they are worthless if nobody uses them. My advice would be to test drive your platform on a real use case before pitching it. I think that in our team, we started having the most success with all of these templates the moment we started using them ourselves for the deployment repositories and everything. Maybe we set up a small POC with a Python backend and a Vue.js frontend to understand the pain points that the developers have to go through in order to be able to pitch them. Because at the end of the day, while it may be simpler in the long run for them to use all of this automation, in the short term, it's a new technology, a new stack that they will have to learn. And finally, automation compounds. Each piece of automation made the next one easier. If you weren't, versioning our templates, Renovate would be useless. So if you find yourself doing something more than once, probably you should try to automate it. And that would be the presentation. Thank you everyone for your attention. If you have any questions.
Cool. Thank you very much, Mircea. Damn, you have a nice flow, right on time.
Thank you.
Do you have any questions? Okay, one there in the back.
Yes, did you say that you have the GitHub resources in Terraform, right?
Yes.
Do you also have the GitHub users and the team memberships in Terraform as well?
For GitHub users, no. We have our own GitHub Enterprise server, and that one integrates with Active Directory, so that is not within my realm of being able to automate. But GitHub teams and team memberships, yes. We have used data sources to fetch the members from our department into Terraform, and then when we set up the teams, you have a list of members, a list of admins for the team, and that's how we do it. And if somebody new joins the department and you need to add them to the team, you just PR that to GitHub, and on the next run, the person will be added to your team, yes.
Okay, then the follow-up will be, if you have to create a PR to add someone in your team, but then let's say that employee gets sacked or whatever, how do you keep it maintainable? Like, I think it's a bit, it gets tedious if you rely on manual operations to keep the team memberships in order. Isn't that correct?
Yes, I could see that being the case if we have like hundreds of teams, let's say. In our department, we have let's say a bunch of teams that are a bit bigger for like the main platform. So in our case, for example, we have, I think, like 4 applications that are like the platform that we provide internally in the bank for our applications, and those would be like the 4 main teams. And we have a lot of, let's say, smaller projects orbiting around those, so microservices within that platform that are made by other people. And those, generally speaking, are, let's say, 2 to 3 person teams. We didn't create dedicated teams within GitHub for those. What we do for those repositories is that the entire dev team is assigned within GitHub as an owner to that project. So we use teams only for, let's say, the big platform level services. And when I say platform, I mean the platform that we offer as a service within the bank.
Okay, because I think for your use case, it can be useful to use the IDP. I think you said Active Directory, to use the IDP as a data source for Terraform.
Yes, that would be ideal. Just like, in my opinion, it would be ideal to have an individual organization per department, but that is unfortunately not my decision to make.
Okay, thank you.
You're welcome.
Cool. Any other questions? Ready to come now? Okay. Actually, I have one question.
Yeah, please.
Very nice the presentation, but my curiosity, who has access to the Kubernetes API, like running kubectl commands? I mean, the entire GitOps setup is very nice, but at the end of the day...
We, as the ops team, have the admin kubeconfig.
Okay.
I think we rarely, if ever, use it with the actual write permissions.
Mm-hmm.
I mostly just sit in K9s all day and make sure that what I push to Git. I mean, honestly, I'm at a point where I'm not even used to do like kubectl apply or Helm install anymore. At this point, if you have asked me to do a deployment, my let's say instinct is to create a Helm release and push it to Git and then watch it happen.
Okay.
I'm genuinely not used to doing kubectl apply or Helm install anymore.
Cool. Thank you very much, Mircea.